Hi, so today we're going to be going over another 2011 MacBook Pro that's having GPU issues. This one doesn't turn on properly, so you hear the chime, you hear the bell, you can see caps locks turning on and off, but on an external monitor or the internal LCD, you see no picture, no nothing, no LCD activation, it's not even distorted, it just doesn't work. Now, I don't have high hopes for the one that I'm doing today, because unfortunately, this one had been fucked with by an idiot. So somebody decided that they were going to try to reball the old GPU instead of replace it, which is how you actually fix these things. And because of that, that's most likely why, instead of it being distorted, you have no video on the screen. So one of the things that I do with all of these, as I've shown you in the last video, is the first thing that I do is bake the board. And the whole idea behind this is that it helps get rid of the moisture and any of the crap that may have built up while it's in storage, or while it's in the middle of winter time in New York City. So I'm about to take it out of the oven now, and like I usually do, I'm probably going to burn myself because I keep forgetting to actually leave work and buy oven mitts. So I'm going to take it out. It's been in there for about 2 hours now. We're at 240, 250 Fahrenheit, around there. Okay, we're just going to do this because it's already done, and time for me to go burn myself. So this is something that you should not do, by the way. You should actually have oven mitts. This is really, really dumb. The thing is, every time I'm actually done with work, I mean, I forget everything. It's like, I don't even remember to buy cat litter or cat food or food for myself. So remembering to buy oven mitts is really, really just something that's not on my priority list. Anyway, I really should remember. So here is the Zhuo Mao ZM-6200c, RRC, whatever, I don't. And let's get started. So the first thing that I'm going to do to this board is add some tape to it. So might as well go over to the workbench here. This desk is nasty, but it's supposed to be nasty because it's a rework desk. So, you got balls and flux and Mac and all sorts of nasty nonsense that you use in the course of rework all over this desk. So I'm totally okay with the fact that it's delaminated destroyed wood, because that's kind of what it's supposed to be. So let's go over to the desk, and I'm going to show you what I do to protect the board while we work on it. So first things first, on this board they put the video RAM right underneath the graphics chip. So since this video RAM over here, these 4 chips on this board, or 2 chips if yours has less VRAM, those chips are right underneath the graphics chip, which means they're going to be getting a lot of the heat. And if you give them too much heat, you wind up actually destroying them. So I use this tape over here to cover them. Now, one of the things about this tape is that it has paper on one side, and under it, here, this is a tape that I got. There's adhesive. Now, this adhesive isn't very bad right now, but when it heats up, it becomes the most nasty, disgusting, vile garbage you've ever seen in your life. So if you actually put this tape on the board like this, and then want to remove it once the job is done, you are going to be stuck with a mess that gets over your hands that I am not kidding. You could wash your hands for 10 minutes with all different types of soaps, with Bronner's, Dove, Dial. It's not coming off. So I would strongly recommend that you don't do that, because that's a terrible, terrible, god-awful way to fix these. And the thing is, when customers open the machine and they see a bunch of goo and syrup and, leftover sperm-looking shit on their board, they're going to look at it like, did these people really do a good job? Do they actually give a crap about my business? Do they even know what they're doing? And you don't want that. Again, when people open the stuff that you work on, you want it to look like it came out of the box, ideally. Even though that's not always possible, that should be the goal that you shoot for. So what I'm going to do here is I'm going to cut up just enough to cover the video memory, and then a little overhang to the other side. I'm going to show you what I do with this. So this is about enough to cover the video memory, and then some. I cut this one a little long. And what I'm going to do is I'm going to tape it to the board with Captain tape. So this tape here, this orange tape, is Captain tape. This stuff is Nashua tape. So let me just get it in here so you could read the label. HAKKO adhesives. And this over here is standard Kapton tape, which you could buy from just about anywhere. Now, the idea behind Kapton tape is that it's heat-resistant tape, so it's not going to fall off while we're doing the work. You don't want to use regular tape that's going to burn and boil and get nasty. The other thing that you want to be careful of, and let me just show you really closely. So let's say I put this Kapton tape across all these resistors over here, right, and these capacitors. These are actually capacitors, not resistors. So let's say I put that little piece of Kapton tape there, which won't go there because it went into a loop because I'm doing a video. Let's try that again. You're not going to win, tape. Alright, so let's say I put the Kapton tape like this, right? Now, what was going to happen with a lot of new people is that they're going to take this tape off in the improper fashion. And when they take this tape off in the improper fashion when it's done, you know what's going to happen to all those capacitors that were soldered there? They're all going to come off on the tape. That's another newbie dumbass mistake that you're going to see maybe a lot of people make. And I know because I made that mistake for the first time about 3 years ago, and you really remember the first time you turn a $500 board in the trash. So you don't want to do that. So what I do here is I look for a spot on the board where I can put my tape that is flat or attached to really large components. So I'm not going to put this thing over a bunch of components that are small. That's a bad idea. I'm going to take my Kapton tape and I'm going to put it right over here. And again, everybody has different ways of doing this. There's really no right way. The right way is the way that works for you and that your customers are happy with. So if you have a different way of doing it, by all means, do it the way that works for you. I'm not trying to tell you in this video that the way that you do BGA rework is wrong. Rather, I'm trying to give people who are doing it for the first time an idea of some of the things they could do to make their life just a little bit easier. So by all means, if you have a method that works great for you and you're making money and stuff works, you probably shouldn't even be watching this. My target audience here are new people. So then I fold it over, and I'll do it over here. I'll put the piece of tape over here right by the screw hole, since there really isn't much to worry about, as you can see. There's just one current sense resistor looking thing over there, but it's big, and I'm not really directly touching it. So right now, my video RAM is protected. Now, the next thing I'm going to do is go over the LVDS mux. Another thing that a lot of people working on these boards don't realize is you're not just taking a chip off and putting it back on. This isn't monkey see, monkey do robot crap. You have to actually take into consideration the things that are going to go wrong with the rest of the board. You have to have a little bit of an idea of how the board actually works. Now, there are some chips on this board that you really don't want to reflow because they will give your life a living hell. One of them is the SMC, which is down here and far enough away that I don't really have to care. So right over there. And then the other thing that I have to worry about is the LVDS mux, which is right here. I worry about this very much because it is a nightmare. If you reflow this, you're pretty much done for. If you reflow that chip, most times if you reflow it, you destroy it and you have to replace it or reball it, and it's 0.25 millimeter balls. Now the thing about 0.25 millimeter balls is it makes the entire process very, very miserable. And also, I don't really know how to find that chip new, so I'd have to source it off a donor board. And the thing about donor boards is you don't know if the donor board was thrown out because the chip that you want from it was dead. So, as you can tell, that's just a situation that altogether, it's best if you avoid. And the way that I try to avoid that is by putting some tape over the mux so that I ensure that I don't reflow it. So, let's see. So I managed to avoid going over a bunch of small things. I'm over one square chip that's fairly big, so I don't believe I have to worry about knocking it off. And also, I'm a bit more experienced at this point, so I'm not as worried about myself knocking things off. I'm just following the practice for the video. And then I put this over here, and there we go. So now the mux itself is covered and protected. Again, it's still going to get hot. Don't get me wrong. It's still going to get hot, but it's just not going to get as hot as it would if I didn't cover that thing. Alright, now the next thing to do is to position this on the station. Okay, so now we're going to position the board on the station. So I have these arms over here, and the entire idea here is that I'm going to position these. You can move these around so that you get these arms in the positions of the holes that are on the motherboard. So the whole idea here is to put this somewhere like this, and then there's also a little screw right here, and the idea with the screw, when you combine it with this little screw, you know, this really is friggin' ghetto looking, but trust me, it works, even though it does look ghetto. You have this little screw over here that's going to be holding up the bottom of the motherboard, so that when I place it down, it's not just like wobbling and gaggling all around. So watch, I'm going to do this. See, I'm placing the board on the holes where the supports are. Should do this from here so that you can actually see. See how it's wobbling and everything? You have to get it in there properly. So you have to get every single one of those in. And once you have those all in, you twist, and you're supported. Now the thing is, it's still going to kind of wiggle back and forth if you don't have it solidly on that little screw. So now what I'm going to do is I'm going to position my camera so that I can see the balls under the chip. I know, it's really hard not to laugh at this stuff, I know. Trust me, you have no idea. You have no idea over the course of a day just how many times myself and the other person here are like, yeah, so like focus on the balls. And we're grown men. Like one of us is pushing 30. I just turned 26, and still, over the course of a day, we can't help ourselves. It's silly. I know, it's ridiculous. It's asinine, but I can't lie. I laugh. I can't help it. That's not really the greatest view. I think we got a little too much light. Further, this is not where it's supposed to be. So see the nozzle versus the chip? It's not really aligned very nicely. I want this nozzle to be directly on top of the chip, and I'm not exactly there. So we're going to move this over, like so. And then we move this up a little bit. The whole idea here is to get the nozzle to where it's precisely on top of the chip. You want it even on all sides. Again, you don't want to be soldering one side of the chip more than the other. That is a really, really god-awful thing to do, and will cause you lots of nightmare, headache, misery, and just don't solder one side of the chip more than the other. You don't want to do that. Alrighty, so that is pretty much aligned to what I can see. It would be funny if it's actually not aligned and you can tell on the camera, but I can't now. Because if that was true, then, you know, you guys would be screaming, it's not aligned, it's not aligned. But there'd be absolutely nothing I can do about it because, you know, I'm in the past and you guys are in the present, or what is to me the future. So, well, let's see what we can do with what we have. Alright, so that is done. Now we're going to go back to the camera here, and we're going to try to align it properly. Hopefully you don't get seasick with all the motion. And the better the view of the balls, the better you know when you're done, and the better you know how much heat to give the board. It doesn't matter what kind of profile you have. What matters is that you can actually see what's going on. Because you can have the best profile in the world. If the wind blows different that day, your profile is going to be different. And so being able to actually see when something is soldered or desoldered is really, really important. And it's something that you want to be able to do when you're working on this stuff. So by all means, take as much time as you want. So my camera used to be aligned perfectly for this, but it's not, because I was actually trying my microscope camera here. I wanted to see if this lens would work on the microscope camera to see if I could use it. But yeah, the point here is you want to get to a point where you have a really good image on the screen. And again, take your sweet ass time in doing this. I mean, you don't even have YouTube viewers watching who are going to complain that they're spending too much time watching you do something. And I do. And I'm still taking my nice sweet time to do this. Yeah, for some, I'm not getting the greatest view here. The view in the other video is immaculate. Here we go. So the idea is not to have too much or too little light. You have to have just the right amount. So I find off focus actually works. I mean, like the light not focusing right on it. And one of the things I like to do is I like to have the chip from here to here, so that I have the largest viewing range where I can see the most amount of balls. Oh my god, I can't help myself. I can't believe I'm saying these things. But yeah, so alright, so that is not as good nearly as what I had last time in the other video, but you can still clearly see the solder balls. And one of the things when I said I was trying to get the microscope camera to work with this, so let me see if I can just show you that for a second. So see that OptiCam that I have over here? That is the microscope camera. Now I can actually put that lens on here. That's a 1080p HDMI camera, so it has HDMI output on it. And the cool thing about that being a 1080p camera with HDMI output at 60 frames per second is it's actually very, very good quality. I paid like $600-700 for that camera when I bought it. Whereas this camera, again, I'm not going to insult it. I'm not going to insult it because it's good for what it is, but it is a cheap piece of crap. So for a cheap piece of crap, this is a great camera. But just keep in mind it's an analog piece of shit, and analog cameras look like junk. It's just the way they work. Analog cameras, like you just get such low resolution, and when you have this single coaxial output going here to this freebie screen that comes with the machine, you know, again, you get what you pay for. I know exactly what I paid for when I got that camera because I know that I paid very little for it, and I can't complain. But yeah, I would like to, in the long term, get something better to be able to view the balls underneath. Because again, I like being able to see what I'm soldering. So now on the machine, I'm going to select the proper profile. So we go BGA select. Here we go, lead free, load. And you can take a look at it, see what my profile looks like, see if it... And you really do need to make your own. And again, even after I made my own, I'm still changing it regularly. And there are actually some things in here that I want to change. There's no reason for the bottom to be going to 260. That's kind of nuts. So I'm actually going to change that because I don't want that. There was another profile on this machine that I saw where bottom heat unleaded. I mean leaded profile. Now you know my password to the machine. Happy? Anyway, the leaded profile on this machine was so ridiculous. It was something like 275 for bottom heat. I actually had RAM chips fall off of a board a while ago because the bottom heat was so ridiculous. Just ridiculous. So that's my profile. Okay. Make sure that the nozzle is in place here. It's a GPU. And you notice one of the things that I didn't actually do here was cover the CPU. Some actually should have done last time. Live and learn. Also, and if you notice, the CPU also doesn't have the edge bonding on it. See? It doesn't have that stuff that it usually does, so it could be that the CPU on this has also been fucked with in addition to the GPU, which is just scary. I hate getting stuff that other people have destroyed. Makes me sad. Because you take my chances of making money and you just kind of poop all over them. You know, I don't poop on other people's chances of making money, so I find it very unfair when people do that to me. Yeah, this is some... Alright, so nozzle, chip alignment. Also, see from last time, I got this little suction piece on it now. There's a little rubber thing there. So this is just about good for me, and I also made sure that this little suction cup that I put there is in the middle of the chip so that it'll actually pick it up. Last time it picked it up, again, I wasn't expecting it to. You have no idea how many times this thing has failed to pick up a chip because it doesn't have that little rubber shit there that it's supposed to. That's one of the things about buying machines from the Chinese is that in general, it doesn't matter what you get or how much money you spend. And I don't mean this to be a cultural insult, it's just, you know, it's pretty much cheap stuff. So, I mean, this was a machine, the Zhuo Mao, as good as it is a machine that's probably a knockoff of something that's made in some other country for like 25, 23,000 bucks. And when you get a knockoff, you kind of have to deal with the things that aren't right. So yeah, on this one, it didn't come with the little suction thing, and the manual was just utterly useless. But the machine itself is good. So we hit start, and we are now runing. See? It says runing. Alright. And we're running a profile. Let's get the whole machine in view while we're working. I'm also going to turn my HAKKO iron on here. So I have my cheaper iron here. I have the one that takes, you know, a good amount of time to actually get started. This iron doesn't turn itself on in, you know, like 4 seconds like my 951. That thing is a good half a minute to get up to the temperature I want, sometimes longer. But it has this, it's not really that accurate either because this is actually a knockoff replacement of the 936. And the 936 is even kind of old in the teeth now to begin with. So what I'm going to do is I'm going to try to do the cleaning, some of the cleaning process over here. So what you see a lot of people do is they run leaded solder or thick leaded solder over the board because it's easier to work with, because it allows you to get rid of the lead-free solder, and it also pretty much makes it easier to, you know, work on the board than if you were using lead-free. Or if you were just to run over the board with wick to clean it, if you were just going to use, let's see, this stuff to clean the board up of the old solder without adding the leaded solder, to do that, it just becomes a royal pain in the ass because you're working with nasty old solder, with nasty old flux, and that's just a really bad thing to do. So that's going to suck up all the nasty odors. Sometimes I forget to turn this thing on, but I remember to turn the fume extractor on as soon as this thing actually gets busy. So yeah, well, the reason I'm going to try to clean up the leaded solder, the lead-free solder, I'm sorry. The reason I'm going to try to clean up the lead-free solder that may be under there, again, I don't even know what's under there because it was fucked with by an idiot, is I'm going to do that work while it's still hot. So while this thing is actually still hot and the board's still on there, that's when I'm going to run this over it while the board is all still hot, and while the board is over here right over these infrared heaters that are going to take a while to cool down once the profile is done. I'm going to pay some good attention here because I have to see when this melts. And since this camera setup kind of looks like crap, it's kind of hard to tell when these melt because it's like watching analog TV in the 1990s when there's a storm outside and there's clouds over your house where there's an antenna. The thing is, I don't know if these are leaded or lead-free. I got to make sure I don't want to run the profile too long, especially since it is a board that has been screwed with and has been put through one heat profile. The more times you run a profile on the board, the more likely you are to screw it up over time. And then, like stuff like reflowing the LVDS mux, you're going to see a lot of new people do that, where they're reflowing a chip that controls the screen, and they replace the GPU, and it doesn't work, and then they replace it again, and then it works even worse because they reflow the LVDS mux even worse, and it's just, it can all go really, really bad, really, really quickly if you don't know what you're doing. Unfortunately, the only way to learn what you're doing is to screw things up. Catch 22. Okay, so my top temperature is at 212. I don't really see any melting yet here. Okay, the top is at 217. We're going to final ramp stage shortly. Yay, there's flux coming from all over the board. There's flux. You can't see this in the camera probably, but there's flux coming out from under the PCH. Oh. Oh, what did you do, you jackass? I'll be so surprised if this shit actually works. You have no idea how happy I'll be if this thing actually works when I'm done with it. So this was probably leaded because I saw balls dropping much before this thing was done. Okay, now I learned my lesson from last time. I learned it very, very well. Do not let the chip drop. Alright, now how do I get this thing to stop sucking it actually? There we go. Okay, this chip I'm going to toss on the desk nastily and mess the balls up just so I remember that it is bad. It's real easy to forget that that's actually the bad chip. Alright, so now what we're going to do is we're going to focus on cleaning the site. I'm going to try to get a better camera angle on this time. Let me get this tripod as tall as it'll go. As fast as I can because the site is actually burning. And it will be cooling down, and as it cools down, it'll be harder for me to clean. Okay. I'm going to try my best to do this from an angle where I'm not blocking the camera, even if it is really, really hella uncomfortable. So, I'm going to add some flux here. Most of it's actually getting burnt away very quickly. And then I'm going to start with my iron. I'm going to make a nice ball, bunch it up, and bring it all around like this. Now, as much as I want to look over and see what this looks like in my little camera screen, I'm scared that if I do that, I'm going to wind up messing up what I'm doing over here and knocking into something. So I'm sorry if you can't see. Truly sorry, but I'm not looking to my right now because I know if I look to my right now that half of these resistors are going to come flying off the board with my luck. Come on, solder blob. There we go. Alright. Let's go over for a second pass. This is not exactly the most comfortable angle for me, but it allows you to see everything. This is going to take me a little longer than it did the other few times. Some solder on here. And the more you do here to get rid of the junk, the more work you do right now, the less work you have to do later. So... You want to try to hit every pad with this ball, but without touching the resistors of the capacitors on the side. If you touch the resistors of the capacitors on the side, your life will become hell. Thank God for this fume extractor, or else this would be awful. I'm doing my best to barely touch the pads, so I don't even want to really lean my iron on here. I'm really just having the solder blob float on the pads with the flux at a really high temperature and pick everything up. The thing is, you can use a really high temperature on the pads and not have to worry about anything. What you really have to worry about is having the iron touch the pads and erode or corrode them. So again, having the big solder blob go over at a high temperature is cool, but touching the pads really harshly, that's where you're going to get into issues and pads that are nasty. So another thing you're going to run into on these boards, again, in almost any board, but this one's more sensitive to it because it is what it is if you are trying to clean the hell out of it over and over again, you are going to screw it up. That is what it is. You don't want to clean the hell out of it and wind up screwing it up. You don't want to like go over it over and over and over again, being this little perfectionist trying to make it look perfect. Because as I say with perfectionism, you're going to wind up destroying something. Every time you strive to do something absolutely perfect, very often reality sets in and you wind up making it actually worse than it would have been. And it would have been perfect if you didn't try to make it perfect. So don't go nuts. Again, me running the solder blob over the board without actually touching the pads does a totally fine job. So now I'm going to use something called MEK. This is methyl ethyl ketone, something that really is nasty to smell. This is kind of gross, but you see that? Ew, yeah, it's gross. I'm using a clean room wiper so that I don't get a bunch of shards of junk on there. And MEK. There is so much to clean off of there. Because not only am I cleaning the flux from this pass, I'm cleaning whatever the idiot who originally did this put on there. This is a good example of why you shouldn't use Q-tips for this. It leaves junk behind. So I'm just going to stick to the clean room wipes. Now keep in mind, I do actually have to lift the leaded solder that I put on there, so I'm not going to go too crazy cleaning it right now, because I'm going to have to redo this again very, very shortly. Okay. Now we're going to take the board over to my desk. I don't have a proper microscope to do this because you can't adjust the magnification. The lowest magnification I have is 10, which is too much. So unfortunately, I'm not going to be able to show you the entire BGA site as I clean. Some of it's going to be out of view, so you're just going to have to live with that. I usually don't even do this under the microscope, actually. I do it usually just on this wooden table over here. So, oh yeah, I forgot I accidentally taped this to the nozzle. Great. Okay, we lift this off. Okay, and we're going to get to cleaning and looking at this under the microscope a little bit. Alright, so the microscope camera is actually so unfit for this application that I'm just using the camera zoom. I'm not going to bother with the microscope. Because the microscope viewable range is actually less than what I see, and what I see is so little already that if I do this under the microscope, you're just not going to see anything. So I'm going to take another clean room wipe and rub the flux around a little bit. Tripod. Yeah, nice try. Tripod's trying to play games with me. Alright. I have a flux brush right behind me. What is wrong with me? Am I nuts? Much better. For some reason, I completely forgot that this was in my possession. That's how you know it's time to go get some food. This is a cool tip. This HAKKO 951 iron has. It's good for this stuff. Yeah, I know the focusing sucks. You know what? Let me actually take the autofocus off. There, so now it's stuck focusing on the board even if I put other things in there. I don't want the thing to be trying to autofocus on my hand and crap every time I move in. Let me turn this on so I don't get cancer from flux. Or at least delay it a little bit. I remember when I said about being a perfectionist. Once you don't want to go over and over and over and over. It's going to be tempting, even if you're somebody who's nasty, even if you're somebody who doesn't give a crap what his repair looks like, just because of basic human nature, you're going to want to go over that one more time to clean it. Truly, don't stop. You've done one cleaning. Go over it to see what spots you missed. Look in a microscope and see where you missed things, and then go over the spots where you missed things. Again, have discipline for this. Just don't go cleaning and cleaning and cleaning and cleaning, because what you're going to do is you're going to wipe the pads off and then you're going to be screwed. It's real easy to do that. Alrighty. And it's not about iron temperature, it's not about the wick you use, it's not about any of this crap or the type of leaded solder you use to replace the lead-free. That has shit to do with it. What it has to do with is your hands, how you use your hands, how many times you choose to go over it. How hard are you pushing with this iron? Are you like going ding and ding, or are you going like really? That's what this shit has to do with. Don't read forums and go over all this crap where they're going, if you have this wick, this will never happen again. If you use this desoldering iron, this will never happen again. Your temps are too high. If you lower your temps, no. It will happen again if you're not doing it properly. What matters is feel. Feel is important. And you have to just get used to what it feels like to rip pad off of this board versus what it feels like to not rip a pad off of this board. So buy some dead, destroyed, damaged, fucked up ones for 15, 20 bucks. Remove the GPU, put it, and then actually feel how much pressure it takes to remove a pad. How many times do you have to go over it with your amount of pressure? I don't know how hard you're pushing with your hands. I'm pushing with my hand a certain amount. There's no way for me to relay to you how hard I am pushing the iron. There's no way for me to relay to you what speed I'm moving this with. That's something that you have to understand through feel. So we can talk about temperatures and the type of flux and the type of solder all day, but what really matters when doing this is that you understand how it feels when you're there. And again, don't be a little OCD lunatic. I mean, if you see that one has a tiniest little bit of solder, just let it go. Only get, again, like, it's going to get melted, I assure you. The only thing you should worry about is if you miss something huge. Because there's this saying that Bob Olson had in a music recording. It's something like, in the attempts to remove everything that is wrong with a take, you also remove everything that it had right. So while you're trying to remove all the things that were bad, you're actually redoing the take over and over again, and you're not looking for what's good. You're not looking for what you did right. When artists have that mindset of listening over and over again to remove all the mistakes, what artists have a tendency to do is ignore all the things that were good. So instead of focusing on making the things that were good better, they focus on taking the things that were bad and removing them. And then you have a song, you have a take, or you have an album where there's nothing that's off pitch, there's nothing that's off key, there's nothing that's in the wrong time in certain places, but there's also nothing that's good about it either, because they tried their damn hardest to make sure that everything was had no errors, while putting no time into listening for, how does that make me feel? Do I enjoy this? Does that make me laugh? Does that make me cry? Does that make me angry? Does this make me feel something? And that's what music is about. I don't know where I got to that from this, but point is, perfectionism is just a fail in so many ways. Good is great. Perfectionism is bullshit. Now I'm going to clean this with the mech, and since I am going to be putting a new chip on here, I do have to be more serious. This actually does have to be a clean site. I mean, you can't have dust and flux residue and also braid residue in the way here. That's bullshit. Being the tiniest bit of residual solder or whatever, but having braid or little pieces of cute, no, none of that. Very good. All right. I wish I had a microscope with different levels of zoom. I finally found the one that I want from Amscope, and it's like 550 bucks. I bought one microscope that was cheap, that did a lot of good things, but it didn't have a camera, and it also was stuck at 10x. I bought this thing because it had a camera, but it has a low working distance. I can't change the magnification, so, you know, that's $400 or $500 spent on this, not including the $600 camera that I got for it. So it's like, I'm just at a point where I'm tired of spending. So, I mean, I would like to do this in the microscope and see the entire thing in the microscope as I go. But I'm done spending money. What? I bought a lot of stuff this year. Okay, so it looks like all my pads are clean, and I'll show you it in the microscope since you asked nicely. Happy. Alright. I'm just scrolling because I have no idea what part of this is in the viewable range. You got some spots like around there that look scary, but I'm assuming that those are power pathways of some sort or a ground plane that are attached together. Again, my hopes for this are low because it was fucked with by an idiot, but let's see what we can do. Alright. Now it's time to prepare the chip and get it put on the board. Okay, so I actually left my chip in the oven for a while longer, since I don't need the chip in the beginning anyway. Yeah, let me show you what we're going to do with the chip. So I have the chip in the oven baking because, as I said, getting rid of the moisture and everything helps you with issues like delamination and popcorning, which is where you see exploding solder balls under the board in a violent fashion, and it's also when you see the green stuff on the board or on the chip start to rise, which means that you're screwed, your job is over. You know as soon as you see that, you can just hit stop on the profile because you're done. If that's the chip, you're done, and you have to start over. If that's on the board, then you're going to go on the internet and find a replacement board for the customer. Because if you delaminate the board, you are highly screwed, and there's really no getting out of that. So I have the chip in the oven actually already in the stencil, and I'm going to show you why, what the whole point of that is. So one of the things you see on a lot of these videos is they throw a bunch of flux all over the board, or all over the chip. I don't like that, because then I actually see it all exploding and everything in real time, and yeah, I'm not burning myself. And I'm not a fan of that. So what I'm going to do here, you're still boiling hot. Ow. I'm an idiot sometimes. I don't know why I'm touching this. What I'm going to do is actually apply the flux only to the balls. So I'm going to use this brush and I'm going to apply the flux only to the balls of the chip. So let's go over to the machine here. I'll also give that a second to melt. I'll also give that a second to cool. So right now it is cooling. I was touching a part of my hand that is completely calloused, so I didn't feel a thing. But if I touch that to a regular part of my hand, I will probably scream in pain like a little girl. So I'm going to let it cool for a little bit. I've let this cool long enough. Going to remove the Captain tape. Put it over here so you can see. Focus. Focus, focus, focus. Come on, we don't want no 360p YouTube videos with crappy techno. Fine. Manual focus. Oh, that's why it's not focusing. We are on manual focus. See, we don't need a cameraman, we just need the video operator to stop being an idiot. Never mind, it still doesn't focus. Manual, back to manual. Alright. That's good enough for rock and roll, as they would say. Okay. So, while this is pushed in there, I'm going to put a bunch of flux all over this chip. Well, no, when I say over the chip, I mean the stencil, because the chip is obviously in the stencil right now. This is Amtech 559. It's good flux. Buy this. And don't buy it from cheap places. Buy it from places like Notebook Mechanics, where you're actually going to get Amtech 559 instead of some little Chinese person's spooge. Okay. Now I'm going to take the brush. I'm going to do this. I want to get flux on every ball. Ah, it got on me. Boo. Well, you can always clean that off later. I really should clean that off now. I suggest that if you get flux on your hands, that you clean it off immediately. But you're not doing a YouTube video, so you don't have to worry about it. I'm confident at this point that I have flux on every ball. So now I'm going to position the chip on the suction thing. Forgive me for not adjusting the camera right now, because I know if I go to adjust the camera, I'm going to drop the chip. So, one thing at a time. I can't help myself. Now I got flux on my camera handle. Alright, autofocus. Come on, focus on the machine. Focus on the nozzle. Here we go. Alright, so I hit manual vacuum on there. Whoa, that's suction. Okay, before, I don't know if you noticed, I used to have to take this thing out and futz with it, and sometimes I'd mess with the flux underneath the chip. None of that right now. That when you put that little piece of rubber there, it just sucks that thing up good. Now to wash my hands before I get cancer. Mrs. Mayer's Clean Day. Liquid hand soap. You should treat yourself to a nice hand soap if you do this crap every day, especially if you're dealing with dirty-ass people's laptops all the time. And not to insult the customers, because like 9 out of every 10 customers is kind of clean, but there's always that one customer that it's just like that little kid in Charlie Brown with the dirty blanket. I mean, you know what I'm talking about when you get a customer that looks like the Charlie Brown dirty blanket kid, and everything you touch is just disgusting, and you compound that with the flux and the solder and the bullshit, and it's like, man, I don't want to touch this BS. Alright, let's get the camera back where you can see everything. Okay, tip, do not crash $2,000 camcorder into wall. Alright. Do not repeatedly crash camcorder into wall. Okay. So that is not remotely aligned. That's actually terrible. That is awful. What the hell is this? Oh, what is this just falling into my camera? Get the hell out of here. I think that was a bar that we used when we ran the electrical wiring for this machine. Alright. So there are these little twisty turny knobs that you can turn to get the alignment of the chip right. So the blue balls are the chip and the yellow balls are the board. I know. Try to resist laughing. It's funny. I know it's funny. I know it's funny. This is not even remotely aligned. It's not good when you have a long way to travel, because the board itself is actually moving over that screw thing. Yeah, I didn't... No bueno. Yeah. Alright. I wasn't actually prepared for it to suck the chip off that well, to be honest with you. That's why. If I were doing that properly, I would have known, like, I'm going to put the chip on over here. But it literally just grabbed the chip out of the stencil. It was not something I was prepared for. Get this away for now. Alright, so let's try this. Okay, so this spool of solder, just so you know, this little spool of solder here fell, and it just so happened to fall right on the switch for the machine, which is why the machine just turned off and the chip dropped into the optical camera. So not only do I have to redo the fluxing of the chip, but I also have to clean the optical camera, which is filled with about 900 little things of flux. This is the kind of stuff that I'm telling you. I mean, this only happens on video. You can't make this stuff up. You can't make this stuff up. I mean, like the solder thing actually knowing to fall at that specific time on this specific thing. That's just, you gotta be kidding me. Alright, so back to the drawing board. So first things first, we're gonna clean this little optical camera. Oh my Jesus. You are gotta be kidding me. We're gonna clean the chip. Alright, I'm just going to toss it in the oven again for a few minutes to get rid of the alcohol and everything from the cleaning of the chip. And that'll also give me time to clean my stencil. Can you believe that, though? I mean, the timing, the spacing, the placing of everything for that to be able to fall. I mean, let me show you. Like, it's down, the switch is down here. I mean, you really get what I'm saying now when I say the worst luck in the world. I mean, look at this, look at this, look at this. So, this here is the switch. Let's try to turn that off again. Like, truly. Okay, this is the solder. Whoops! Like, what are the chances of it hitting that? What? Like, let me just try that again while I'm waiting for that. Whoops. 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 Like, are you kidding me? I mean, that it actually decides to hit the switch while it's up there. Well, not only while the chip is up there, but in the middle of a video. I mean, that's just... You really have to laugh at some things, or else you would just cry at the unfairness of it all. So I'm not going to show you the cleaning and the putting the flux on the stencil again, because I already did that on camera, and you already know how that works. I'm also not going to edit this out of the video just because it was inconvenient and highly humiliating. Because as I've said, in the real world, things don't always go as you planned. In my real world, things almost never go as I plan. Time again. Try again. Yeah, alrighty. Okay, now back to our originally scheduled programming, which is where I wash my hands again to avoid cancer. I really should buy latex gloves or something. I mean, latex gloves are probably an equally effective way of avoiding getting cancer from touching flux all the time. I'm going to put that on my to-do list today. I have to get cat litter, to go to the gym, and I have to get gloves so that I don't get cancer. Gym, cat litter, then gloves, though. That's fair order. It's important to stay in shape, you know. You gotta prioritize things in life. Alright, let's move this camera so it's actually comfortable for me. Who am I kidding? I'm in a 200 square foot room. Nothing's ever gonna be comfortable for me. This is like a 150, 200 square foot room. Gotta love New York. Alright, so alignment. Any funny business want to happen now? That's what I thought. Alright. Move over. Here. You can watch the fun part. Zoom in. You don't have to really go through doing it this much. It's just... Thing is, I paid the extra to have a machine where I can go nuts if I so please, so... And this is my way of getting my money's worth. It's also like a sick little video game. Zoom out. This is good. That is good. Alright, now we bring the chip down on the board. Zhuo Mao. Zhuo Mao. No funny business, machine. No funny business. Alright. I'm going to block the camera for a second, and my apologies for doing so, but it is really important that I can visually confirm that what I'm seeing in the camera is real. That the chip is in fact aligned. Hello? Hello? How are you? Checking. Alright, so yeah, my friend and... Alright, so yeah, the guy who just came in was actually my first boss for my first real job in Manhattan. Dave Levitt from Progressive Music. So, a long time no see, so I went to talk to him. And back to this. So I take off manual vacuum. And once manual vacuum's been off for a second, I'm gonna... You mother. Tell me you just moved my chip. Alright. You know what? Enough has gone wrong tonight that I'm actually just willing to risk it. I really think that this actually moved my chip. Even though I turned manual vacuum off and lifted it, that little rubber piece that I put there, the little rubber piece that's supposed to suck up the chip, may have actually moved it out of alignment. But yeah, let's take a look in the camera. Because I just saw the thing move a little. I don't know if that was just my eyes deceiving me because it's late. But so this over here, this little ball, which you can't see, this, which you still can't see, this, so that's a pad, that's a ball, that's a pad, that's a ball, it's a pad, that's a ball, and the rest of it is just blurry bullshit, but... Alright, so let's hope that this is good. Let's see how many mistakes I can cram into one video. Alright, let's make sure that the chip is right in the middle, because again, as I said, you do not want to be soldering one side more than the other. It's bad. Okay, I'm going to take this little rubber thing out so it doesn't suck the chip up. Though with my luck today, it probably will. Alright, let's see what happens here. Here goes nothing. Start. Ruining. A little over to the left. Okay. And also let's turn this thing on so that the smell doesn't kill me. If the smell doesn't kill me, then the noise will. Okay, how many things can go wrong in one evening? Let's see. So watch the balls melt. We're only at a top temperature of 50 Celsius, a bottom temperature of 126, and an infrared of 66, so we're not going to be seeing anything real happen just yet. And I might as well throw this in here just for kicks. I'm not taping this to the board. This is a thermocouple, so it's going to be way, way off. Just out of sheer curiosity, let's see what it says. I'm placing it next to the chip. Awesome. You want to adjust, honestly, you're not adjusting it so you can see one thing perfectly. You want to adjust it to where you can see the pad and the ball. So pad, ball, pad, ball. You wanted to see those two distinct spheres. So the thin one is going to be the pad, and obviously the thicker, rounder one is going to be the ball. Whew. Now it's really, really, really important once the top heater kicks in that you watch this. Because the thing is, this looks like such crap because of the combination of the heat, the flux, the fact that you have no space, and the shitty camera. This looks like such shit that it's really hard to tell when the ball is melted, about to melt, versus solid. So you need to be staring at it perfectly so that you know exactly when it started to melt. You can look at the time and tell exactly how long you're going so that you have an idea what's going on. You need to just stare at this monitor for 3 or 4 minutes. And I know it's a pain in the ass. I know it seems like a waste of time, especially if you're impatient and don't like paying attention to things like I do. But if you want to make the money and you want the thing to actually work properly when you're done with it, this is what you do. So the top temperature is up to 174, real temperature is 160. So usually the top temperature lags the temperature on the bottom of the chip by about 20 Celsius, so that thermocouple, since it's a little bit outside the bottom of the chip, is looking correct. So this is the ball that I'm going to be most interested in watching drop because it's the one that I can most clearly see. So I'm watching this one right here. The flux is activated. We're up to 211 top temperature, 184 next to the chip. Now when you see stuff like that move, that is the flux moving, that is not the solder balls. Because they obviously, lead-free solder balls cannot melt when the top temperature is only 202 Celsius. So don't get fooled by that. Don't get fooled by this shit moving in the background. Don't get fooled that that solder ball is melting. You want to look at the outer balls. That's what you have a good view of. You want to look at this ball. I honestly just really look at that ball first. That's the one that I'm mainly focusing on. So we're up to a top temperature of 212, a real temperature, which is the thermocouple of 200. Very soon, we're going to see some melting going on. Focus here. Top temperature is 217, and it's been there for a while. Now we're close to going into the final ramp stage. So in a second, we're going to go to the final ramp-up stage, and at the ramp-up stage is when you're going to see the heat, is when you're going to see the melting here. Well, let's see how much the chip shifts as well. If the chip shifts like crazy, I know it's just totally misaligned. So the chip just dropped. We're on the final ramp stage, so give it like maybe another 10 seconds. So this is pretty much melted. About 10 seconds after all this melts, okay, and the chip dropped. I'm going to take the nozzle up a little bit. No need to burn it. Stop, we're done. Bring it up. And you're going to start watching and you're going to see that the balls are actually going to turn solid soon. See? You saw one turn solid. That one turned solid. This is the one that's going to be the most noticeable. Okay. And we're going to let it cool for a little bit. So I just turned on manual cooling, which is where the nozzles start shooting out air, but they're shooting out cold air. There's no heating element on. So we're going to let that sit for a little bit. So I'm just going to remember, as a reminder, this is the old chip that I'm going to put over here. That old chip is going to go back on if this board winds up having been screwed from the original work that was done to it. So that chip got dropped onto the optical camera. After being dropped onto the optical camera, I put it back. I put it on there after reapplying the flux and cleaning it before reapplying the flux. This nozzle actually moved it because the suction was so strong on this little rubber piece that the little suction from the rubber piece didn't want to let go of the chip. And this is a board that had been fucked with before I touched it. What do you think is going to happen when I turn it on? Any bets? This is still boiling. We're going to get a shortcut to cooling this off. Right, here's the air compressor, so I'm pretty far away. My thermocouple says I'm at 32 Celsius. Yeah, I'm good to go. Alright. So, turn this off, this freaking noise machine. Unscrew this, unscrew this, unscrew this. Yes, noise machine. This is the moment of truth. How good do you think my luck is? My poking stick. This is my touchscreen stylus. Yeah, you like that, right? Okay. Let's remove the tape. Oh, here's one of the things I wanted to show in the last video that I wasn't able to. You see how nice this all looks when you use the tape properly? The tape itself is nasty, but you see how the VRAM looks great and there's no nasty shit and there's no glue everywhere, because you don't want to get that stuff all over you. It's disgusting. It really is disgusting. Get the tape off. I've taken no components off of the board with the tape. That's excellent. Going to examine some of my work under the microscope, see what it looks like. I see soldered balls in place, so I have... You know what, I actually got that feeling in my gut just now, the one that I told you about in the last video. You know that feeling when you feel so confident that something's going to work that you don't even bother testing it before you put it in the machine? That's how I'm feeling right now. And if I had thermal paste, I would feel even that much more confident. Yeah, I ran out, so I got to open this one. Alright, let's open the thermal paste. I'm feeling good about this. I don't even care that you got fucked with by an idiot who used a heat gun. I'm feeling good. That's important. You gotta feel like the stuff that you're gonna do is just, you have to have this confidence that everything you do is gonna work before you even test it. Because that's the stuff that winds up actually working. Even though I already cleaned this stuff before, I'm cleaning it again because it probably got dust or any sort of junk on it in the meantime. So all this heat sink, all this thermal compound, I don't just go over it once and go blah, 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 blah with a toothbrush. I knock all of that junk off of the board. I don't want a single speck of anything sitting in between my heatsink and my processor or my new video chip other than very, very cleanly applied thermal paste. Keep in mind, this is a big reason that this crap fails to begin with. They use junk thermal paste and a shitty heatsink, and I can't really change the shitty heatsink, but at the very least I can change the shitty thermal paste. So the thermal paste that I use here is Tunic TX4. If you want to go Google right now, so right now it is December of 2014, there is very little in terms of thermal paste that is better than this. And yes, I actually was enough of an OCD freak to read reviews of thermal paste. And you know, and I know that every single site is going to have a different bias or different testing methodology, but so many websites have this as ranked as like the best one amongst 5 or 10 or 15 others. When you have enough sites that agree on one thing, very often it is actually true. So at the very least when it comes to benchmarking. So you have one site that's a little like off all the others, then you have to question whether the majority are wrong or whether the minority are wrong, but it's not just the majority or the minority. Virtually, if you Google right now and you just look for the reviews, almost every site shows Tunic TX4, this little tube that I just used, as being some of the best stuff that you can get, even though it is, you know, it's $12 for this bullshit little tube. It's like another couple of bucks for shipping. So it does cost good money, but I don't, again, as I say in all these videos, I don't want to see this guy again. I want to see him again if he's going to buy candy next door. I want to see him again if he's walking by with his dog and he just happens to see me and say hi. I don't want to see him again with this laptop. I never want to see him again with this laptop unless maybe he wants to get an SSD to replace this junky Toshiba 500 gig mechanical drive that's in here. So I do whatever I can to keep people from actually having to come back here for the same thing. What kills me is I was reading this thread, I think it was Mac Rumors, I'm not 100% certain. It was where this person was saying, yes, Apple uses Shin Itsu paste. Where do I source the Shin Itsu paste so I can have the exact same that Apple uses? I mean, there again, I don't make fun of Apple users for being brainwashed. I'm not one of those people. If you use Apple products and they work for you, as I've said in many other videos, use Apple products and they work for you and they help you make money and you like them, God bless you. Again, I want them to work for you to make money. But when you say, I want to use the exact same thermal paste that Apple uses, you're brainwashed. You just are, because you are so brainwashed into the idea that everything this company does is perfect that you can't see the things that they do that are clearly asinine, ridiculously wrong. And the thermal paste that they use, it's just bullshit. It's complete bullshit. And, you know, there are a lot of companies that I like, but I admit the things that they do that are violently, horribly wrong. I love Lenovo. They're an amazing manufacturer that, you know, has, over the last year, fucked up their product line terribly and destroyed it, and I've done videos on it. You know, a true fan of something, a true fan of a company or a product or an artist is somebody who is going to admit when they've done something wrong and provide that feedback. Because you see, if we don't provide feedback when the company does something wrong, then how are they supposed to know that they did something wrong, and how are they supposed to learn from it? You think you're doing a good thing by always standing by a company or always standing by a product or an artist when they're doing something that's god-awful terrible, but the reality is that they're not going to know that they're doing something terrible unless you tell them. Now, there's this quote from Oscar Wilde that I think really applies here, which is, real friends stab you in the front. The idea is that they're not, you know, they say that your enemies stab you in the back, so those are people who are going to sneak up on you and say bad things or cost you your job or your promotion, or, you know, cheat, like, they're going to get your wife to cheat on you with them and things like that when you're not looking. But real friends are the people who are actually going to say, listen, man, I'm sorry to say this, we've been friends for 10 years, but I'm in love with your wife, and I told her about it. You know, again, it may seem like a scummy thing to do, but the real friends are the ones that, when push comes to shove, are going to stab you in the front. My dad always used to comment on this and go, you know, and my stepmom and go, you know, real friends don't stab you at all. You know, but that was taking it a little too literally, in my opinion. But, you know, if you believe a company is amazing and great and you want to support them, you know, tell them. They're using thermal paste that is complete bullshit. They're using heat sinks and thermal designs that are complete bullshit, and it's screwing up their products. Because they need to know. Because they'll change once they know. But they can't change if they don't know. Whoops, wrong screw almost. Those two screws are the smaller ones. Yeah, I'm being a little too cocky right now. I mean, for all I know, the guy who brought me this laptop is the one who tried to reflow it with a hairdryer or a heat gun and burned his everything. Okay, time to play Dentist, my favorite game of the days. Say L board. Okay, this is not being a technician, this is being a dental assistant. Look at this, look at the tools that I'm using to do this, like, come on. Say battery connector, trackpad connector, keyboard connector, battery indicator flex, speaker, hard drive cable, optical drive cable, say webcam cable, Wi-Fi cable. This is not electronics at this point. This is dental work. Man, I really do feel cocky. I'm actually plugging in all this stuff already. I mean, there's no need to plug in all this stuff just to see if I get a picture on the screen that doesn't have lines on it. I'm feeling really cocky right now. Oh, I'm even plugging in the webcam. Man, I got some long-term thinking going on here. I'm never taking this board out again. Okay, let's get the RAM. I gotta plug both RAM sticks in instead of one. So not only am I cocky that my GPU works, I'm cocky that I didn't kill the RAM slot. A lot of people kill the RAM slot. You have no idea. You have no idea. You may be thinking to yourself, how do you kill the RAM slot doing this? The heat is not even near you. You have no clue. You don't know until you deal with companies and employees and everybody who you come into contact with that just loves killing the RAM slot. Here's the moment of truth. Do you chime? Oh, I forgot, you chime and turn off because that's what this piece of crap board does. So don't be scared by that, by the way, if this is your first time working on this. When you turn it on, it really does do that. It just turns on and turns off for no reason. Like, I remember thinking, oh my god, I broke it. Oh my god, I broke it the first time. And admittedly, the second, the third, the fourth. By the fifth, it was humiliating. But eventually, you know, when you get to number 2,000 or 4,000, you realize that this machine actually does do that. It just turns itself on and then turns itself off before it chimes. This is chiming, and let's see if I get an apple with lines. Oh my god, the apple has no lines in it. Alright, so I am going to screw this in. See? Cockiness. It worked. This has nothing to do with the fact that I have a $7,300 machine to solder the chip, or 17 years electronics experience, or any of that. This has to do with cockiness. That's why this chip works. This chip works because of positive energy. That's what it is. I had the positive energy that this was going to work from the moment that I turned it on. From the moment that I started putting it back in the computer, that positive energy, that really does it. Because when you think it's not going to work, and you're like, it's not going to work, you're already used to, you expect it to not work, so you don't really do the things that you should do to make sure that it works. You know, if when I drop the chip on the board, like in the last video, I'm like, oh, this is screwed. You know, do you think that I'm going to bother making sure that everything's clean? Do you think I'm going to bother making sure that there are no shorts? Do you think I'm going to bother 100% if I think that my work is screwed and done? Do you think I'm going to care that, you know, that there's to get every single last solder blob or last bit of residual solder off when I'm cleaning with that big solder ball? Do you think I'm going to care if I knock off a component on the side? Do you think I'm going to look with that extra bit of accuracy to make sure that that solder blob does not touch the resistors on the side? I'm probably not, because you're in that mindset where you expect that your work has failed. You expect that it's dead. This is still booting because it uses a mechanical drive. Fucking piece of crap. But once you're in that mindset where you just know that your work works, everything that you do winds up coming out at a higher level of quality. I can legitimately put every single screw in here while I'm waiting for a Toshiba 500 gigabyte mechanical drive to boot. Like, really. You gotta do better than this shit. Apple should be kicked in the nuts for using mechanical drives on any of these. And I know that this machine came out in 2011-12, but still. You see what the thing costs. Alright. Okay, so I logged into guest user. So in the last video, I actually got a troll saying, you never showed us it working, you just showed us a blink. That's because every time I show the computer working, every time, you find some little memo with the phone number of the person's girlfriend or some crap on the desktop, and you make a comment of it in the notes, and that person winds up getting a phone call, and they're like, why am I getting trolls from YouTube? Like, are you filming my stuff? Are you taking my data? So no. Okay, so this is logged into guest mode. So what I'm going to show you right now to show you that this works, albeit slowly with that shitty Toshiba drive, what I'm going to do is I'm going to open Photo Booth, because Photo Booth activates the discrete GPU inside the machine. So if you have messed up video when it's just standard regular in the OS, or you have that green fuzzy shit, that could be an Intel integrated video problem. But if you have lines only when you open Photo Booth, that could be a problem with the GPU. So I'm not going to run ASD yet because my gym actually closes in, let's see. Yikes, it closes in 40 minutes and I gotta get running over there. So I spent extra time doing this. So all I'm gonna do is I'm gonna force quit this join Wi-Fi bullshit. Because honestly, if the drive in this computer is dead, I don't even care right now. I can deal with that shit tomorrow. I really just want to see that my GPU works. Holy, come on. What, are you fucking kidding me? Like, this is the thing about mechanical drives. Mechanical drives, it's not like mechanical drives are standard and then SSDs are fast. Mechanical drives are broken. Like, once you get used to using an SSD, a mechanical drive in the machine actually feels broken. Like, my friend said that, you know, he gave his dad a few machines and he set them up, and for a moment the guy had to go back to using a machine with a drive, and that his dad kept calling him into the room to say, the machine is broken, it has a beach ball, what is this spinning thing, there's a beach ball, it's broken. And it's like, he said, no, Dad, it's not broken. You're just going from your PCI Express solid state drive with like 1 gigabyte per second read speed to a 500 gigabyte Toshiba. So as you can see, I've opened Photo Booth, and even though it's taking forever because of the garbage mechanical drive, you don't have lines down the screen or color distortion or any of that bull crap. So the GPU is actually working fine. And again, this thing can get Apple Service Diagnostic tested and firm-marked and all that good stuff tomorrow. I got to get going to the gym, or else I am going to miss it. And again, the cool thing here is that not only... Okay, let's go over the stuff that happened to this. It was reflowed or reballed by a moron. Then a second moron worked on it and took the chip that he was going to use on this machine and dropped it straight into the optical camera of the BGA rework station. After that, I put the chip on the board, and while I was placing it on the board, it moved because I forgot to remove the little piece of rubber suction. So I'm only supposed to use that to pick the chip up, not to actually put it back. So it actually got moved completely, which is why you had to see it move so far back into place at the end of the profile. And after all of this crap, this process was still what? Like, again, including video, including me taking my sweet-ass time because I'm doing a video and adjusting the camera a million times in the middle. Whole thing's like an hour, hour and 30 minutes. There's really no reason. There's no reason with a good machine, if you know what you're doing, that this process from start to finish should take more than an hour and a half. There is absolutely no reason. When you get a Zhuo Mao ZM-R6200c, you should be able to blaze through, if you're not videotaping this, you should be able to blaze through 7 a day. If you're not a jackass like me and you're actually fast at BGA rework and you're not dropping shit and screwing shit up the entire way, you should be able to do maybe 10 or 20 of these a day with this machine. Truly, seriously. So, you know, you should ask about buying one. Because again, you could buy the cheapo-ass Scodel, you could buy the cheap-ass like Scottle stuff and the Honton stuff. And I shouldn't compare Honton to Scottle because Honton seems like a better brand than Scottle, even the Jovi stuff. But when you buy a machine like this, everything it just works. I mean, you can see what you're doing well with the camera system. You can align the chip properly with the placement system. And, you know, the profile runs the same every time. That's what I like. Because with that Scodel that I had, my biggest complaint with the Scodel IR6000 V4 that I had is that every time I ran a profile, the curve was completely different. I wasn't out of my mind. I hooked it up to the computer. 3 p.m. I ran the profile. I started off with the machine totally cold. It did this. Then I let it cool down completely. I ran it again at 4:15. The room temperature could not have changed more than like 1 degree. It did this. Then I let it run again at 5:45. It did this. Like every single time I ran it, it was something different, which means every single time you run it, you're going to be screwing up a board. The cool thing about the Zhuo Mao ZM-R6200c that I got from Advanced Reworks, every time you run this machine, I mean every time you run it, it does the exact same thing. And if you're looking to do volume, if you're looking to make money off of this, what you need are repeatable results. You need the same thing to happen every time you touch that machine. Because again, I'm trying to think big with this. I don't want to think about like, okay, I'm going to save 500, I'm going to save 1,000 here, and I'm only going to add maybe 10 minutes to my work time a day. I may only mess up one more job a day. I'm thinking in terms of I want to do 10 or 20 of these a day. That's where I want my company to be. I want to be at a point where 10 or 20 BGA jobs a day ain't nothing but a thing. And if I want to be at that point where it ain't nothing but a thing, as Aaliyah would have said, and age ain't nothing but a number, I need to have good equipment. I need to have tools that minimize things not working right. Do you need alignment system? No, you can align it yourself, but that increases the factor of human error. Do I need the camera system? No, but it decreases the factor of the profile not working the way it's supposed to because the weather changed or something, or that board started off less hot or whatever. You know, do I need a profile to run exactly the same every time? Well, actually, yes, I do. I'm not putting up with a profile that runs different anytime. And when you buy this machine, it really does work wonders. So, and also there are a lot of people out there that are selling this that are not exactly selling legit stuff. So one of the comments on a forum that I'm on, this guy, I asked about the price of the machine, and I told him about $7,300, and he goes, "Oh, I bought it directly from factory. When I buy direct from factory, it's only $4,000." I'm not kidding when I tell you that literally like 2 days later, this guy was posting on this forum going, "Help! I popcorn all my chips. I need help with profile. It not working. It popcorn all my chips." And it's like, yeah. Do you want to spend $7,300 on a professional rework station or $4,300 on an easy bake oven? Because here's the thing, if I'm spending like $100 versus $200, I may go with the cheap thing just because Worst case scenario, I'm out $100. But if I'm spending like $4,000 to $7,000, I'm gonna cry if I lose 4,000. I'm not gonna cry over $100. I'm not gonna cry over $100. But if I spend $4,000 on something and it winds up being an easy bake oven, I may just break down and cry, or you know, wind up going on a killing spree and shooting everybody, because that is something that's it's sad. So you know, spend the money right the first time. You know, there's a saying in the music industry when it comes to getting nice microphones, because everybody in the music industry starting out is usually broke. You know, beg, borrow, or steal. I'd really recommend avoiding the third one, but the first and the second one, you know, beg and borrow to get the tools that you need. And yeah. So I showed everything from start to finish, and as you can see, the job looked fairly clean. So I zoomed in on the bottom of the board. And again, one of the things that I want people to see when they open my work, when they open the bottom cover of a machine that I worked on, I want it to look like, oh my God, you can barely even tell that you replaced the GPU. It looks great. That's what I want people to think. I want people to get the impression that the work done here is quality. I don't want them to get the impression that I tested their computer by playing 1080p high-definition porno and then spooging on the board and mixing it with a little bit of flux afterwards. Because, you know, there are boards, you know, there are boards where it really does look like that, and they've come from, not mentioning where. Gonna keep my mouth shut on that one, but you just, it's nasty. I mean, if you have to do rework on it, or let's say the customer breaks their screen after you fix their GPU and they try to replace their own screen and they blow a backlight fuse, you got to open that again, and you really don't want to touch what looks like a bunch of spooge. It's just, it's disgusting. So take my tips on how to use the tape properly so you don't wind up getting that spoogey junk all over the board. Take my tips on what to cover while you do the rework so that you don't reflow things that kill it. Again, there's nothing worse than starting, like, you don't want to be the guy who starts off with distorted video and then has no video at the end of it. You don't want to be the guy who fucks up the LVDS mux because he doesn't even know how the board works. You know, you want to be the person who can do the job repeatably once every hour. Because again, if you get good at this, again, I'm not good at this. BGA rework is like, again, look, I'm dropping chips on machines. I'm dropping I dropped the solder onto the switch. I mean, I'm a joke, and still, hour and a half or so. You want to get to a point where you're doing this in 45 minutes to an hour consistently. So yeah, this is about it, and just to show it starting up again, to prove that I am not full of shit. We're gonna turn it on. I'll edit out the video when it gets to his boot screen, because I know you trolls are gonna look him up in the white pages and call his house and say you're on YouTube, and just do things that trolls do. This had no image before. Also, you may have noticed that this video is actually in sync because I am recording to two crucial MX100 SSDs in RAID 0, and I'm not recording to. Not only was I not recording to SSDs last time, I actually noticed that the RAID array that I created out of them while I was waiting for the SSDs was from white label hard drives. So they're like, they're probably Western Digital's shit didn't work pile. I don't know where I found those things from, but. Yeah, this is a mechanical hard drive for you. Okay, we're going to cover the username so no trolls can happen here. But as you can see, we booted up into the app of the screen. Has an apple on it. And I'm done. I'm just one of the last things I do when I'm done. I have the chargers right by the slots here. So I actually plug them in. I like for people to. That's another thing I'm talking about, impressions. And when you're charging for service, for looking at every little thing you do, I want him to see that he has 100% battery when he gets this back. I want him to actually pick it up and notice that not only does it work, but it's cleaner than it was before. The keys don't have little sticky stuff on it like it did before. And that it's 100% fully charged. So even if you dropped it off here at 0%, you should leave at least 50, 100% charged. But anyway, that's the whole thing. So if you have any questions on this machine, you should go to the advancedreworks.com forum. So advancedreworks.com/forum. Join. Ask questions about the machines. Don't buy the cheap shit. Don't buy the cheap shit. You know, again, the owner, David, is going to disagree with me on some things. And a lot of people there are actually going to disagree with me on a lot. But just avoid the cheap shit. Like, if you're going to do this work, at the very least, start with something like the Joe VR 8500, or start with something that you're not going to have to upgrade from later. Like this machine that I have here, again, I'm going to have this machine until I'm at a point where I'm doing 100 a day, and even then I'm just going to buy like another one of these things. You really don't need more than this, but buy something that you're not going to have to upgrade. Don't make the mistake I did. Don't buy a Scottle IR6000. And can you do work on it? Yes. Can you do volume, repeatable work on it? Hell no. Again, if you can, God bless you. You're a better tech than I am. But I would suggest you save up to get something good. This is a 3-year-old machine. This, in my opinion, is a junky 3-year-old machine. I can still sell that machine for $750 to $900 if I upgrade it right, or even. And the thing about that machine is, you really only have to sell maybe like 7 or 9 of them to pay for a machine like the one that I have. Truly. So think about that when you're thinking about buying a $400 rework station. Think about that before you buy that Puhui, like Puai or whatever, T62. I mean, it's telling you in the name, like pronounce it in English. It's Poo. Seriously. Like, think about that before you buy the cheapest thing from Skodal or the cheapest thing from Akshi. Again, like the stuff that came from AHCI or ACHI or whatever the fuck you spell it, that stuff was literally going on fire. People had to actually modify their wiring when they got these machines so that they would not go on fire. Just think about the stuff. Think about it before you buy it. Not even about making the machines work. Not even about doing proper BGA rework. Just about keeping your shirt from going on fire while you're working on stuff, you know. Because it may surprise you, but the safety standards and everything that they have for a product to be sold in Kmart is not the same that they have for a product in China to be sold when it's exported to America. But yeah, I'm just rambling at this point. I gotta go. Gym closes in a half hour. Hope you learned something.